Hi everyone, I'm Roshini here. With me, Shindu and Farhan is here to discuss about a topic known as conics. This topic we are having in the semester 2 session, mathematics. So, we are here to discuss about the topic of conics. Conics is a section which is obtained from a curve as the intersection of the surface of a cone with the plane. And from the picture I've included here, we can see there is an axis of symmetry and there is a generator, there is an upper nap, lower nap, and the angle between the axis of symmetry and generator. And another thing that should be taken into consideration most importantly is about the beta, where we can see between the plane and the axis of symmetry, where we can differentiate what is ellipse, what is circles and parabola. Do you guys thinking what is ellipse, what is circle, what is parabola? Okay, I can say conics is divided by three, which is known as ellipse, circles, ellipse, and parabola. Circles will be having a beta equals to alpha, and also ellipse parabola will be having a beta equals to alpha too. Ellipse will be having an angle where the beta is bigger than alpha and lesser than pi over 2, which is 90 degrees. So we will see what is circles. A circle is a set of all the points that have equal distance called radius to a fixed point which is called center. Center will be having a coordinates of h and k, where the angle at x and y at the circle will be having a coordinates of x and y, and that 2-point connecting will be known as radius. Radius can be determined by Pythagoras theorem. When we are using the Pythagoras theorem between these 2 points, we will be having an equation where r is equals to square root of x minus h square plus y minus k square. And that can be simplified into r square equals to x minus h square plus y minus k square. That is the standard form of circles. So second part of conics will be ellipse. Ellipse having 2 parts, which is the vertical and horizontal. The horizontal will be having a formula of x minus h square over a square plus y minus k square over b square equals to 1, where we can see over there. The thing should be take into consideration for ellipse is all about co-vertex, focus, and the center. How about vertical of ellipse? That the formula will be taken into consideration will be x minus h square over b square plus y minus k square over a square equals to 1. We will go to the third part of parabola, the third part of conics, which is parabola. Parabola will be having an angle where the beta is bigger than alpha and lesser than 90 degrees. So the thing should be taken into consideration for parabola will be vertex, directrix, focus, axis of symmetry, and the center too. So we will see the formula. The formula for the vertical axis will be x minus h square plus 4p y minus k. The second part of a parabola will be having a formula of y minus k square plus equals to 4p x minus h. So we will see a question which can relate our daily life to conics. So through here we can see a question where we can relate the conics to our daily life. I think we are daily using the bridge. Have you ever think what bridge and conics are related to? So we will see a question about it and how we will try to solve the question too. So we will see the question. Parabolic cable of a 60-meter portion of the roadbed of a suspension bridge are positioned as shown below. Vertical cables are spaced between every 6 meters along this portion of the roadbed. Calculate the length of the first 2 of these vertical cables from the vertex. So we will see how to solve it. To solve this question, we need to draw a diagram with the coordinates and that can be determined from the question. So the coordinates to be determined from the question will be 0 and 3, 30 and 16, and another 2 will be having a unknown where 6 and y. Y we don't know. Where x, 12 and x, we don't know the x too. So we need to find the x and we need to find the y. We need to find the length of the height of the first vertical cable and the second vertical cable. Okay. So for that we need the formula to be used here. The formula to be used here will be x minus h square plus equals to 4p y minus k, which is the vertical parabola formula. So to solve this question, we need to substitute the value we know first. The value we know first will be 0 and 3. We need to substitute the value of 0 and 3 into the formula x minus h square equals to 4p y minus 3. So we will be getting the first equation. Second, we have to substitute the second value, which is the 30 and 60, into the same equation, which is x minus h square equals to 4p y minus k. So we'll be getting the second equation. After that, we need to substitute the third equation too. After the third equation, we need to substitute all the values of first equation and second equation to be used, and we can find out the answer that the height of the first vertical cable is C1 and D1 equals to 3.52, and the height of the second vertical cable is C2, D2 is 5.08. So I think through this solution we can see how relatable conics in our daily life, where we are using the bridge every day. Have you anyone think about it? So after this, please think about it. Thank you.
The second question of conics is about parabola, the water fountain. The oldest water fountain is the fountain in Piazza Santa Maria in Trastevere, and it is a fountain located in the square in front of the Church of Santa Maria in Trastevere, Rome, Italy. This is a diagram of fountain in Piazza Santa Maria in Trastevere, and this is our modern style of water fountain. In the last time, the uses of water fountain is to provide drinking water and water for bathing and washing to the residents. Nowadays, water fountain is used for decoration and celebrate their builders. Let us look at our question. At a water fountain, water attains a maximum height of 4 meters at horizontal distance of 0.5 meters from its origin. If the path of water is a parabola, find the height of water at a horizontal distance of 0.75 meters from the point of origin. So we pick the point from here. Our h is 4.0 meter, x is 0.5 meter from the origin, and our maximum height is 0.5 and 4. So maximum height is 0.5 and 4, and it is the parabola shape which is open downward. By using the formula x minus h square equals to 4p multiplied with y minus k, the equation of the path of a water fountain is x minus 0.5 square equals to negative 4p multiplied with y minus 4. The negative here indicates the parabola which is open downward. By substitute the origin coordinate 0.00, we will get that p is equals to 1 over 64. So the p here, we substitute the value inside the 1. So we will get the second equation, which is x minus 0.5 square equals to negative 1 over 16 y minus 4. To find the height of the fountain at a distance 0.75 meter from the origin, which is x equals to 0.75, by substituting the coordinate p, which is 0.75 and y1 into the second equation, we will get that 0.205 square equals to negative 1 over 16 y1 minus 4. So after we calculate 0.205 square, it is 1 over 16, and negative 1 over 16 multiplied with y1 minus 4. By dividing 1 over 16 and negative 1 over 16, we will get 1, and expanding negative y1 minus 4, we will get negative y1 plus 4. So our y1 is equals to 3, y1 which is the y for p coordinate. So the height of water fountain at a distance 0.75 meter from the origin is 3 meter. Thank you.
Hey, great presentation Shiro. Now it's my turn to present to you another question about kinetics. Hi and welcome everyone. Before I forget, I am Farhan, the last presenter for this group, the Maths PiRates. Today, I will present to you another one question that applied the concept of kinetics in real life under the subtopic ellipses. So my subject that connect to ellipses is mountain tunnel. So, what is mountain tunnel? With more than 6 million kilometers of highways and 240,000 kilometers of railways snaking across the United States, life above ground has become increasingly congested. Tunnels provide some of the less available space for cars and trains, water and sewage, even power and communication lines. Today, it's safe to bow through mountains and burrow beneath oceans. But it was not always this way. In fact, it took engineers thousands of years to perfect the art of digging tunnels. Today, not even mountains and oceans stand in the way. With the latest tunnel construction and technology, engineers can bow through mountains, under rivers, and beneath bustling cities. Before carving a tunnel, engineers investigate ground conditions by analyzing soil and rock samples and drilling test holes. And now, cars and vehicles can go through a mountain using this mountain tunnel. In the right side, we can see the mountain tunnel that is the title holder of the world's deepest and longest rail tunnel through the mountain, and we also can see the Zion Mountain Carmel Tunnel. Now enough of the interesting fact. Now let's dive to our question. So now this is question applying kinetics in real life. So our question is, a tunnel through a mountain for a 4-lane highway is to have an elliptical opening. The total width of the highway, not the opening, is to be 60 meter. And the height at the edge of the road must be sufficient for a truck 4 meter height to clear. If the highest point of the opening is to be 5 meter approximately, how wide must the opening be? So now guys, we go straight to the solution. On the left, we got the sketch of the mountain tunnel with the information given based on the questions. On the right hand side, we can state the information given and we can see the total width of the highway AB equals to 60 meter, as we can refer to the sketch and transfer it to make it easy. We also given that the highest point of the opening OC equals to 5 meter. We also can see from the sketch that DE is the end of the opening at which a truck of 4 meter high has to clear. To find the width of the opening, D prime whose ends DE and D prime E prime that height of 4 meter, we have to choose the center of the ellipse as the origin and highway as the major axis along x-axis. And we given that OA, as we can refer to the sketch on the left, as semi-major axis small a equals to 8 meter and OC equals to semi-minor axis small b equals to 5 meter. Now we can use the equation of the ellipse, which is x squared over a squared plus y squared over b squared equals to 1. And now we substitute the semi-major axis small a and semi-minor axis small b into the equation, and we got x squared over 8 at 8 squared plus y squared over 5 squared equals to 1, and that is the first equation. So then we let the coordinates of E be x4 and E is a point on the ellipse. So we just do the calculation using the equation given to make x as a subject. So here is the equation. So here is the calculation. And we got x equals to 4.8 meter. So we can conclude that OD equals to 4.8. So D prime is 2 times OD. So we can equals that to 2 times 4.8 meter. And we got D prime equals to 9.6 meter. So we can see that the width of the opening is 9.6 meter, as D prime represent the width of the opening of the mountain tunnel. So that is the calculation and the answer for the question. So now guys, we have come to an end of our presentation. I hope you understand our presentation and enjoy it. Thank you for watching, and especially thank you to Madam Emma for this incredible opportunity. May we have fun and productive learning session ahead. Welcome to the Connect World. Sincerely from us, the Maths PiRates.